The jump strategy. We do this strategy because it's great mental computation practice, and it also reinforces understanding of place value. The jump strategy is done by jumping forwards or backwards by the largest digit value through to the digit of least value. For example, if you were going to subtract 54, you would subtract 5 jumps of 10 first, and then the 4 smaller jumps for the units. Here's an example question to see how we apply this strategy. 76 subtract 35. We're going to record this on a number line because then we can easily see our steps and check to see that we've got each step correct. So we're going to start at 76, and our first step is to subtract the tens, which is 30. And 30 is 3 jumps of 10. Let's see what that looks like. So I started with 76 on the right side of the page because it just reminds me that I'm jumping backwards and I won't make a mistake of jumping forwards accidentally. So I've labelled up the top of each jump to remind myself to jump back 10, and I've also labelled it underneath. As students become more confident, they won't need to do this labelling, but when you're starting, it's a good idea because you can easily check all your steps. So I've got 76, 66, 56, 46, and I've jumped backwards my 3 lots of 10 for my 30. My next step, of course, is to count back the 5 units. So now I've done some smaller jumps for the units, and I've written subtract 1 up the top, and I'm up to 46. I've labelled that before, so I haven't lost my place. 46, 45, 44, 43, 42, 41, and my answer is 41, and I've popped it up here to finish my number sentence. Now, if students are having difficulty keeping track, you certainly may label under each jump. I haven't done it here simply because it's tricky to fit the numbers in. And as I said before, as students become more confident, you won't need to label everything. They'll be able to do it very quickly and pop their working out down nice and confidently and accurately. The jump strategy can also be applied to larger numbers, such as 854 subtract 135. It's exactly the same method. We're going to start with the largest digit value, which is the 1, which stands for 100. Once again, I've got my 854 on the right side of my page to remind myself I'm taking away. Here is my first jump completed. I've started at 854 and I've labelled it for myself to remind myself I'm jumping back just 100. Also, I've underlined the hundreds to remind myself that's the only digit I actually need to look at. 854, 754. My next step is to take away the 3, which is worth 3 tens, 3 jumps of 10s. Here are my 3 jumps of 10s. Again, I've labelled them to remind myself I'm jumping back by 10. I'm starting at 754 and I'm jumping by 10s only. I could also underline the tens column to remind me they are the digits I'm looking at. So you can see where the place value understanding comes into play. 754, 744, 734, 724. My last step, of course, is to count back the 5 for the 5 units. Okay, here's my 5 smaller jumps for my 5 units, and I'm going to say it out loud and use my finger again just to make sure I've got everything correct and I'm staying accurate. 724, 723, 722, 721, 720, 719. If students are getting confused with saying the 7 for the 700 every time, of course you could just stick with the 24, 23, 22, 21, 20 and 19, and just remind them at the end to put the 700 back on at the beginning. And of course we come up to our original question, 854 subtract 135 equals 719, and that is using the jump strategy.